I'm now going to discuss Chapter 15.5, Part 2. We're going to talk about clades and cladistics. The first part is talking about cladistics as a system of classification which groups taxa together according to their characteristics which have most recently evolved. So what we're talking about is in a diagram such as this. This is a cladogram. We have the common ancestor back here. And this common ancestor is going to have the one characteristic. This characteristic can now change and it will make a new species. This characteristic will change and will make a new species. And this is going to have in common everything below it. And when we have a new species, we call that a clade. A clade is a group of organisms that have evolved from a common ancestor. To decide how closely they're related, we're going to look at the primitive and the derived traits. Primitive traits are the characteristics which have the same structure and function. They evolved early in the organism. A derived trait now is going to be the same structure and function, but where they evolved into more recent modifications of a previous trait. And so we're going to have a trait that the primitive traits the ancestor would have had that will now change in some way and evolve, and we'll call that a derived trait. Kind of like maybe it used to be a leg in the primitive and now it has evolved into a fin or something like that. When we do have a group that can split into two parts, having certain derived traits that the other doesn't have, we now call them separate clades. And so when they have two different kind of traits, in other words, a new species, we're going to be called a clade. So in order to put the organisms into their appropriate categories, we have to look at the characteristics. One characteristic we're going to look at is homologous characteristics, one derived from the same part of a common ancestor. I put down a definition as same structure with a different function. And this is going to involve a common ancestor. Again, same structure, but they're going to have different functions. The example that they give is the five-finger limbs, in which we have, they're going to have the same kind of bones, but they're going to have a different function. And so it could be like the same bones, it might be a wing, and it might be a hand or a foot, but they're all going to have the same function, even though they have the same structure. Conclusion that organisms that possess these limbs have a common ancestor. In a second, you're going to see some photos that's going to help you with that definition. Analogous characteristics are different structure, same function. They're not going to have a common ancestor. Again, different structure, same function. We might have something like wings. A wing of an eagle, mosquito, and a bat. These are totally not related to each other, but they're going to have the same function as being wings. Another thing we can look at is with fins. Sharks and dolphins both have a pectoral fin. They have similar functions, but a shark is a fish and a dolphin is a mammal. So they're not from the same kind of cladogram, because they're totally different types of organisms. But they do have something that resembles the same, so it's analogous. How are cladograms made? They represent to represent the findings of all these characteristics, where we're going to use it in a visual way, and this visual way is called a cladogram. And looking at this, we're going to have the shark is going to be like the common ancestor, and then the dolphin is going to be the most recent species that has split off of there. How you make it is you're going to make a list of organisms, and they're going to list all the possible characteristics. Here's some examples of some characteristics. Well, let's look at an example of how to make one. What you do is you're going to make a list. Notice we have all the different characteristics going across and the animals going down, and then you make a checklist of everything you have in common. Notice a sponge only has one thing in common with everything, but an elephant has everything in common. And so the sponge is going to be the common ancestor with only one thing in common. So here's the sponge. It is multicellular. Notice all of these are multicellular. But the sailfish has two things in common. It has a vertebral column, so that's a sailfish, but the sponge does not. The wombat has hair, but the sailfish and the sponge does not. And then the elephant has a placenta, but these do not. So notice each one has more characteristics, but the elephant has all the characteristics below. And that's how they're related in a cladogram. Why are they constructed? They're constructed to show the evolutionary relationships. Branches are going to start at the bottom of the cladogram, are the earliest ones that have evolved, and the ones at the top are going to be the ones of the most recent organisms. So the elephant would have been the most recent species made in this cladogram. Next, what we want you to do is we want you to construct a cladogram. I would like for you to turn this in on a separate sheet of paper. These are the steps you should do. These are the organisms, and these are the characteristics. First thing you gotta do is we make a list of the organism, list of the characteristics, and then make a table. If you look at the next page, they have made a table for you, and so they got the table made for you. If you just copy this table down, put a check mark on everything, and look at the totals. Whichever one has the least amount of totals is going to be the common ancestor, and then you just work your way up to one with the most totals. And now at the bottom of this page is going to be the answer for you, so don't look at the answers until you've gone through this. So this is the example of how to make one. What does the cladogram tell you? It shows, like for instance for here, it shows for koalas, for example, evolved after the hawks because they possess the derived characteristics of hair. So the koalas, here's the hawk with no hair, and now we have the koalas with hair, so it's going to be derived later. It also says that a cladogram that any two organisms found on successive branches are more closely related than those which are separated by one or more nodes. So the camel is more closely related to the koala than the camel is to like the shark, because they're going to be the most closest relationship that has evolved. And that is the end of the talk that we have to do. What I need you to do now is to continue the rest of this video, and at the bottom we have some pictures to help you out, to help you come up with some more definitions and some more answers I have you to do. So finish the rest of the worksheet down below.